Dear students, in the previous video I explained about definition of hyperbola, some important properties, standard form and transformed form of hyperbola, length of the lattice rectum. The important topic is rectangular hyperbola and auxiliary circle. Okay, some more important properties also you learned in that video. Okay, so now in this video I am going to explain about the condition for tangency and point of contact, eccentric angle and parametric equations, equation of tangent in different forms, equation of normal in different forms, asymptotes. Here important topic is asymptotes. Next, director circle, some example problems. Okay, so this already I said in previous video that if you are perfect in ellipse chapter, so if you learn all the properties of ellipse like tangent equation, normal equation, etc., everything, if you learn perfectly, then it is very easy to learn. Okay, right, so that's why concentrate, practice previous chapters, parabola, ellipse carefully, then you will understand hyperbola easily. Okay, right. So first topic is condition for tangency and point of contact. Before going to learn condition for tangency, first of all I will explain about eccentric angle and parametric equations. Okay, so what do you mean by eccentric angle? Already this terminology you learn in ellipse. So here this is called as auxiliary circle. Auxiliary circle means it is a circle with a diameter as transverse axis. Okay, right. So now eccentric angle. So before, let px comma y be a point on hyperbola and m is the projection. M is the projection means it is a perpendicular on a projection on transverse axis. Next, here draw a tangent to auxiliary circle which meets at Q. Here MQ is the tangent. And C is the center of the circle. X square plus y square is equal to a square. This is the circle. X square plus y square is equal to a square with radius a and center 0, 0. Center is 0, 0, right? Now draw a line segment from C to this Q, this is tangent now. So this angle MCQ, let this angle be theta. So this is called as eccentric angle. MCQ is called as eccentric angle. Next, from this triangle, let this is x comma y, then this distance from center to M distance is x and this is a. From this right angle triangle, what is cos theta? Cos theta is equal to adjacent side, that is a by x, right? From this x by a is equal to what? Sec theta. Okay, x by a is equal to sec theta, x is equal to a sec theta. So here this point is on the circle, the parametric form is a cos theta comma a sin theta, right? Already you learnt in circles. So that is a cos theta comma a sin theta, and this is the form, x is the form a sec theta. X value we got a sec theta. Next, substitute this x is equal to a sec theta. That point is on hyperbola, right? So substitute in hyperbola equation. So you will get a square sec square theta by a square minus y square by b square is equals to 1. A square cancel. Y square by b square is equal to secant square theta minus 1, which is equals to tan square theta. So y square is equal to b square tan square theta, then y is equal to what? Plus or minus b tan theta. Okay, so a sec theta comma b tan theta, this is a sec theta comma minus b tan theta. Okay, so this is the P is the corresponding point of Q. P is the corresponding point of Q which is in the parametric form. So therefore x is equal to a sec theta and y is equal to b tan theta are called as parametric equations of hyperbola. So here the point is of the form P of theta, that is a sec theta comma b tan theta, where theta lies between 0 to 2 pi, 0 to 2 pi, and here the condition is sec and tan not defined at odd multiples of pi by 2. So theta not equal to pi by 2, theta is not equal to 3 pi by 2. Okay, so these are the parametric equations of hyperbola. Okay, next, point of intersection of the ellipse and a straight line. Okay, so this is the ellipse, not ellipse, this is hyperbola. Point of intersection of the hyperbola and a straight line. So this is the equation figure of hyperbola. So straight line may intersect like this. Don't think these two are two pieces, these two are separate curves. So this is a graph, this is a graph of hyperbola, this is the combination of two curves. Okay, those two curves are in opposite side. So this opens left side, right side, this opens left side, this is the combination of two pieces. Okay, right. So the line may intersect at 2 points. This is called as secant line. The line may touch like this. So this is called as tangent line, and this is also tangent. These two are parallel tangents. Okay, so slopes of these two tangents are equal, and this is the tangent. These are the tangents will not cut the hyperbola. Okay, so tangent, the line may intersect at 2 points, this is called as secant line. The line may touch the hyperbola, that is called as tangent. The line may not intersect the hyperbola. Okay, so here I given solution already I solved in ellipse module. So here solve substitute y is equal to mx plus c in equation number 1. So you will get mx plus c whole square, squaring on both sides, and convert it into as a quadratic equation in terms of x, rearrange the terms. Okay, so here I am deriving a condition for tangency. Tangent avvadaniki condition. Tangent avvalante, so a line is said to be tangent to a given curve if discriminant it has only one 0. That means discriminant is equal to 0. So that means b square minus 4ac is equal to 0. Simplify this one. Well, finally you will get c square is equal to a square m square minus b square. This is the condition for tangency. Okay, so a line is said to be tangent to the hyperbola, then the condition is c square is equal to a square m square minus b square, then c is equal to plus or minus under root of a square minus m square minus b square. Those two tangents are y is equal to mx plus or minus. These are two tangents in slope form. Okay, two tangents. Now point of contact. Solve same like ellipse, then you will get point of contact as minus a square m by c minus b square by c, a square m by c and b square by c. So two negatives, two positives. So like this we will get 2 point of contact, right? Okay, so this is about point of contact of ellipse and line. A line touches a hyperbola. Okay, then point of contact is this one. Next, if line is of the form lx plus my plus n is equal to 0, then what is the condition? So compare with this one. So convert into my is equal to minus lx minus n, y is equal to minus l by m into x plus minus n by m. So what is our condition? C square is equal to a square m square minus b square, right? So minus n by m whole square is equals, this is c, this is m, right? Y is equal to mx plus c. So we have this condition. A square means a square only, m square minus l by m whole square minus b square. So finally n square by m square, here m square LCM, a square l square minus b square m square. M square cancel. So what is the condition? If the line is of the form Lx plus my plus n is equal to 0, then the condition for tangency is n square a square l square minus b square m square. This is the condition. So in ellipse we have plus symbol, here minus symbol. Only minor changes are there. Okay, so study these concepts. Next, equation of tangent in different forms. So one is point form, second one is parametric form, and third one is slope form. First one, point form. The equation of the tangent to hyperbola s is equal to 0 at given point p x1 y1 is s1 is equals to 0. So in circle, parabola, ellipse, hyperbola, in all cases, in all conic sections, the tangent equation is s1 is equals to 0, right? So now x square by a square minus y square by b square is equal to 1 is the equation of the ellipse. P x1 y1 be a point on the ellipse, so it lies on this equation number 1. Therefore x1 square by a square minus y1 square by b square is equal to 1, right? So now differentiate this 1 with respect to x to find the slope. To find the slope, differentiate with respect to x, you will get 2x by a square minus 2y dash by b square is equal to 0. Okay, so 2 common and cut, so you will get y dash by b square is equal to x by a square. From this y dash is equal to b square x by a square y. So y dash is nothing but dy by dx, that is the slope of the tangent, slope of the curve at x1 y1 point is b square x1 by a square y1. This is the slope of the curve at x1 y1. So slope of the tangent also same at this point. Therefore we got slope point and slope. Slope is equal to what? B square x1 by a square y1. Now what is the equation of the tangent formula? Y minus y1 is equal to m b square x1 by a square y1 into x minus x1. So y minus y1, here careful simplification, bring b square by y1 to left hand side, you will get y1 by b square is equal to x1 by a square into x minus x1. Now y1 by b square minus y1 square by b square is equal to x1 by a square minus x1 square by a square. Okay, so bring this one and bring this one. So x1 square by a square minus y1 square by b square is equal to x1 by a square minus y1 by b square. So this is 1. So therefore finally x1 by a square minus y1 by b square is equal to 1, which is minus 1 is equal to 0, which is s1 is equal to 0. So this is the equation of the tangent to the hyperbola at px1 y1 is s1 is equal to 0. That means x1 by a square minus y1 by b square minus 1 is equals to 0, right? Now it is I am going to find in parametric form. To find the to find tangent equation in parametric form, what is the point in parametric form? A sec theta, b tan theta, right? So substitute in this equation, you will get x into a sec theta by a square, okay, x1 value, minus y into b tan theta by b square is equals to 1. So 1a gets cancelled, 1b gets cancelled. So finally x sec theta by a minus y tan theta by b is equal to 1. This is the equation of the tangent in parametric form. The conditions are theta not equals to pi by 2 comma 3 pi by 2. That is not defined, sec theta tan theta. Okay, so finally slope form, just now we derived y is equal to mx plus c. What is c? plus or minus under root of c value a square m square minus b square. So this is the equation of the tangent in slope form, right? So these are the important three forms of equation of the tangent to given hyperbola. Next, equation of normal in different forms. First one is point form. So this is the point form, same as ellipse. Okay, so change only change occurs at symbol, plus become minus, minus become plus, minus change with plus. This is the parametric form. So here how to derive this normal form. Okay, so slope of the tangent is just we derived b square x1 by a square y1. Then what is the slope of the normal? Slope of the normal is equal to reciprocate and change the symbol, minus a square y1 by b square x1, right? So now we got the slope of the normal, then we can find the equation of the normal which is perpendicular to tangent and passing through x1 y1. So y minus y1 is equal to minus a square y1 by b square x1 into x minus x1, right? Okay, so now bring what a square b square by y1 to left hand side. You will get y minus y1 minus a square by x1 into x minus x1. So multiply to inside, b square y by y1 minus b square y1 gets cancelled, minus a square x by x1 minus into minus plus x1 cancel. So bring to left side, rearrange the terms. A square x by x1 plus b square y by y1 is equal to a square plus b square. Here this is the equation of the normal, okay, in point form. So if we substitute x is equal to a sec theta, y is equal to b tan theta, then you will get a square x by a sec theta, b square y by b tan theta is equals to a square plus b square. One a gets cancelled, one b gets cancelled. Ax by sec theta plus by by tan theta is equals to a square by b square. So this is the parametric form. So a square plus b square is nothing but if we take a square as common, then we will get 1 plus b square by a square. So this is the formula of e square. So a square into e square. This also can be written as a square into e square. Now observe this condition, y1 not equal to 0. It is in denominator. Why he did not mention x1 not equal to 0? So in hyperbola x it will not touch y axis. Therefore x1 may never be 0. So that's why he did not mention that condition. If y1 is equal to 0, what happens? If y1 is equal to 0, then this x-axis is the normal. Okay, so at vertex y1 is equal to 0 at vertex only. So at vertex the x-axis is the normal. Okay, the slope of the normal here slope of the normal is 0, and here at the vertices there are two tangents called vertical tangents. Vertical tangents exist at where vertices only, and there are no horizontal tangents. Observe, there are no horizontal tangents. Vertical tangents exist, but they exist at vertices. For those equations are x is equal minus a and x is equal to a. So this is the discussion about equation of the tangent and equation of the normal. నెక్స్ట్ ఇంపార్టెంట్ టాపిక్ అసిమ్టోట్స్ ఆఫ్ హైపర్బోలా. ఈ అసిమ్టోట్స్ అనే పదం కంటే ఇంగ్లీష్లో చెప్పడం కంటే తెలుగులో దీన్ని ఏమంటారంటే అనంత స్పర్శరేఖలు. స్పర్శరేఖలు అంటే ట్యాంజెంట్ లైన్స్, స్పర్శ టచ్ చేసే లైన్స్ అనమాట. అసిమ్టోట్స్ ఆఫ్ హైపర్బోలా తెలుగులో ఏమంటారు? అనంత స్పర్శరేఖలు. అనంతం అంటే ఇన్ఫినిటీ, స్పర్శరేఖలు అంటే ట్యాంజెంట్. అంటే ఇన్ఫినిటీ దగ్గర ఈ హైపర్బోలాకి ఒక లైన్ కనుక ట్యాంజెంట్ అయినట్లయితే ఇన్ఫినిటీ దగ్గర, ఇన్ఫినిటీ అవుతుందా? ఇన్ఫినిటీ అంటే లార్జ్ వాల్యూ దగ్గర ఒకవేళ ఈ లైన్ కనుక ట్యాంజెంట్ అయినట్లయితే దాన్ని ఏమంటారంటే అసిమ్టోట్ అంటారు. అసిమ్టోట్. Okay, so another definition is a non-vertical line, it is a not vertical line, a non-vertical line with equation y is equal to mx plus c, means it is a straight line, is called an asymptote of the graph of y is equal to f of x. ఈ y is equal to f of x is a graph, దానికి y is equal to mx plus c అనేది అసిమ్టోట్ అవ్వాలంటే ఈ గ్రాఫ్కి ఈ mx plus cకి మధ్యన కనుక డిఫరెన్స్ ఏమవ్వాలి, యాజ్ ఎక్స్ అప్రోచెస్ టు ఇన్ఫినిటీ ఆర్ యాజ్ ఎక్స్ అప్రోచెస్ టు మైనస్ ఇన్ఫినిటీ. అంటే ఎక్స్ ఇటు మైనస్ ఇన్ఫినిటీకి పోయిన ఫస్ట్ ప్లస్ ఇన్ఫినిటీకి పోయినప్పుడు ఇన్ఫినిటీని అప్రోచ్ అయినప్పుడు ఇప్పుడు వీటి మధ్యన డిఫరెన్స్ ఎంత ఉంది, 3-4 ఉందనుకోండి, 4, 3, 2, 1, 0.9, 0.8, 0.7, 0.6, 0.5, 0.1, 0.001, 0.0001 అలా ఇన్ఫినిటీకి వెళ్ళిన కొద్ది వాటి మధ్యన డిస్టెన్స్ ఏమైతే ఉంటే తగ్గుతూ ఉంటుంది. దట్ అప్రోచెస్ టు దట్ టెన్స్ టు 0, దట్ మీన్స్ ఇది ఇన్ఫినిటీకి వెళ్ళిన కొద్దీ వాటి మధ్యన డిఫరెన్స్ అనేది దేన్ని అప్రోచ్ అవుతుంది, 0ని అప్రోచ్ అవ్వడం. అంటే ఏంటిది, 0 అవ్వదు. ఓకే, 0ని అప్రోచ్ అవ్వడం అంటే 0.00001 అట్లా కావచ్చు అనమాట. అంత లెంత్ అంత దగ్గరగా వెళ్తాయి అనమాట, ఇన్ఫినిటీ వరకు వెళ్ళిన కొద్దీ అంత క్లోజ్ అయిపోతూ ఉంటాయి. ఓకే, సో ఈ రెండు కూడా ఇటు క్లోజ్ అవుతూ ఉంటాయి. సో ఫ్రెండ్స్ అనమాట, కలిసి వెళ్తూ ఉంటాయి. ఇన్ఫినిటీకి వెళ్ళిన కొద్దీ భయం కాకుండా కలిసి వెళ్తాయి అని అర్థం చేసుకోండి, రైట్. సో అందుకనే వీటిని ఏమంటారు, అనంత స్పర్శరేఖలు. ఇటువైపు కూడా ఎక్స్ టెన్స్ టు మైనస్ ఇన్ఫినిటీ అయినా కూడా అలానే. సో దిస్ ఈజ్ ద బ్యూటీ ఆఫ్ అసిమ్టోట్. వీటిని ఎలా ఫైండ్ అవుట్ చేయాలి? ఓకే, సో ఫర్ దట్ x² - y² b² +or-1 అంటే ఇంకోటి -1 కూడా ఇలా ఉంటుంది కదా, దాన్ని కూడా ఇది అవుతాయి. దిస్ ఈజ్ ద సెకండ్ టైప్ ఆఫ్ హైపర్బోలా, రైట్. సో దానికి కూడా ఇవే అసిమ్టోట్స్ అవుతాయి. సో టు ఫైండ్ ది ఈక్వేషన్స్ ఆఫ్ అసిమ్టోట్స్, ఈక్వేట్ x² / a² - y² / b² ఈజ్ ఈక్వల్ టు 0. ఈక్వేట్ చేస్తే మనకు వచ్చేస్తాయి. ఏంటి అవి? సో ఫ్రమ్ దిస్ y² / b² ఈజ్ ఈక్వల్ టు వాట్, x² / a², y² ఈజ్ ఈక్వల్ టు b² / a² ఇంటూ x², remove square root square, y is equal +or- b by a into x. One is y is equal b by x and another one is y is equal -b by ax. These are two asymptotes for given hyperbola. One is y is equal b by ax and another one is y is equal -b by x. These are two asymptotes. Okay, so this is of the form y is equal to mx plus, so this passes through origin. So here slope is b by a and here slope is -b by a. So these are the important points about asymptotes. So remember these points. Okay, right. Next topic, director circle. The circle x² + y² is equal to a² - b² is called as director circle of hyperbola s is equal to 0. How it forms, how it generates? Okay, see here, the point of the locus of the point of intersection of two perpendicular tangents to the hyperbola. That means, so these two are tangents, right, which intersect perpendicularly. Okay, these are perpendicular tangents to this hyperbola. These also perpendicular tangents. Like this, we have infinitely many perpendicular tangents are there. So here these two tangents intersect here, some more two tangents intersect here, like this. So if we add those all points, we will get a circle. Whose radius is a² - b². Center is at origin. Okay, center at origin and radius is at a² - b². How can we solve this problem? Okay, solution. What is the equation of the hyperbola? x² / a² - y² / b² is equal to 1. Okay, right. Px1 y1 be a point on locus. Px1 y1 be a point on locus. Now discussion is about tangent lines, right? So equation of tangent. equation of tangents. What is that? Y is equals to mx plus c. That means y minus mx is equal to plus or minus a square m square minus b square. Y is equal to mx plus or minus a square. Slope form of the tangent equation, right? Now px1 y1 lies on this tangent. So px1 y1 lies on 2. So therefore it satisfies, right? Now squaring on both sides. So you will get y1 minus mx1 whole square is equal to, squaring means it becomes plus, square root cancel, a square m square minus b square, right? So now y1 square plus m square x1 square minus 2 m x1 y1 minus a square m square plus b square is equals to 0. So m square taking as common, what is remaining? x1 square minus a square minus 2 x1 y1 into m plus y1 square plus b square is equal to 0. So this is a quadratic equation. This is a quadratic equation in terms of m. This is having roots m1 m2 as zeros. Okay, m1 is the slope of one tangent, m2 is slope of another tangent. Here we got two roots. So what is the formula for product of roots? This is a quadratic equation in terms of m, right? So what is the product of roots? m1 m2 is equal c by a. C by a means y1 square b square plus b square by x1 square minus a square. So as they are mutually perpendicular tangents to each other, so the product of slopes is equals to minus 1. So minus 1 is equal to y1 square plus b square by x1 square minus a square. So do cross multiplication, you will get minus x1 square plus a square is equal to y1 square plus b square. So rearrange terms, you will get x1 square plus y1 square is equal to a square minus b square. So this is the locus of these perpendicular tangents. So this is required locus, and this is called as director circle. So in ellipse, the director circle is x1 square plus y1 square is equal to a square plus b square. So there also we will get perpendicular tangents, we will get outside. So that is x square plus y square is equal to a square plus b square. Here x square plus y square is equal to a square minus b square is the director circle. Next, the concepts are completed almost. So now it is time to solve related problems of explained concepts. Okay, so first problem is, if E and E1 are the eccentricities of hyperbola and conjugate hyperbola, then prove that 1 by E square plus 1 by E1 square is equal to 1. Okay, so simple problem. Let x square by a square minus y square by b square is equal to 1 is hyperbola. Then eccentricity of this hyperbola E square is nothing but a square plus b square by a square plus b square by a square. So this implies 1 by e square is equal to what? Reciprocate this one, a square by a square plus b square, equation number 1. Next, conjugate hyperbola, x square by a square minus y square by b square is equal to minus 1. So eccentricity e1 square is equal to actually under root, e1 is equal to under root. So e1 square is equal to a square plus b square by, here denominator it contains b square, here a square, here b square for this hyperbola. 1 by e1 square, reciprocate that one, b square by a square plus b square. This is equation number 2. So now the question is left hand side. I'll take a left hand side. So LHS is 1 by e square plus 1 by e1 square, that is a square by a square plus b square plus b square by a square plus b square. So here LCM is a square plus b square, a square plus b square, then answer is 1. Therefore E and E1 are eccentricities of hyperbola and its conjugate hyperbola. Then 1 by e square plus 1 by e1 square is equals to 1. Next, similar problem to previous point, that is if eccentricity of hyperbola is pi by 4, that is E is equal to pi by 4, then find the eccentricity of its conjugate hyperbola. So we should find E1. So what is the formula? 1 by E square plus 1 by E1 square is equals to 1. 1 by E square is nothing but E is equal to 5 by 4. From this 1 by E is equal to what? 4 by 5. 1 by E square means 16 by 25 plus 1 by E1 square is equal to 1. 1 by E1 square is equal to 1 minus 16 by 25. 25 LCM, 25 minus 16, 9 by 25. So 1 by E1 square is equal to 3 by 5 whole square. 1 by 1 is equal to 3 by 5. Then E1 is equal to what? 5 by 3. So this is the eccentricity of the conjugate hyperbola of given hyperbola. So to solve this problem, you should remember this condition, that is 1 by E square plus 1 by E1 square is equals to 1. Next, find the center, foci, eccentricity and equation of the directrices, length of the lattice rectum of this given equation. Okay, so this type of problem we did in parabola and as well as in ellipse. Okay, so the way of solving this problem is convert this problem into completing square method. By using completing square method, we have to convert this into any 4 forms. Okay, any one of the form of 4 forms. Okay, right. So for that, this is x terms. These are x terms. Write in one bracket 5x square plus 20x. Next, minus common, 4y square minus 8y is equals to 4. From these two, I took minus as common. So 5 taking as common, x square plus 4x. Here minus 4 common, y square minus 2y is equals to 4. 5 into a square plus 2ab. A square plus 2 to the 4x, right? 2ab. So a square plus 2ab means we should add b square, that means 2 square, and subtract it. Minus 4 into here also y square minus 2 into y into 1, add 1 square, subtract 1 square is equals to 4. Now this is the term 5 into 5, don't forget 5. 5 into x plus 2 whole square minus 5 4s are 20. 4 into y minus 1 whole square minus 4 into minus 1 plus 4 is equal to 4. 4 gets cancelled. Now 5 into x plus 2 whole square minus 4 into y minus 1 whole square is equals to 20. Divide with 20, we will get x plus 2 whole square by 4 minus y minus 1 whole square by 5 is equal to 1. Divide all terms with 20, you will get this form. So this is the transformed form, and which is of the form x minus h whole square by a square minus y minus k whole square by b square is equal to 1. Now here, what is h? So that is of the shape like this, center shifted to some h comma k. Okay, right. Remember all formulas. First of all, what is h? H value, compare. H value is minus 2, k value minus k minus 1, k value 1, a square 4, then b square 5, a 2, b root 5. From this, e is equal to, for this type of hyperbola, eccentricity formula is e square by b square. Okay, a square plus b square by under root of b square. Now under root of a square 4, here a square 4 plus 5 by a square 4 plus 5 9, root 9 3, 4 root of 4 2. So eccentricity, therefore eccentricity is 3 by 2. Okay, so we got eccentricity. Next, remaining remaining terms we should find those are, first one, center. What is the formula for center? H comma k, right? Center is h comma k, so that means minus 2 comma 1. And foci, actually foci is plus or minus ae comma 0. Here add h units, that means h plus or minus ae comma k. So h minus 2 plus or minus a 2 into e 3 by 2 comma k 1, 2 to cancel, so 1 take minus 2 plus 3 comma 1 and minus 2 minus 3 comma 1. So foci are 1 comma 1 and minus 5 comma 1, 1 comma 1 minus 5 comma 1, right? Next, center completed, foci completed, eccentricity also completed. Equation of directrices. Equation of directrices. X is equals to y is equal to x is equal to actual plus or minus a by e. So here h plus or minus a by e. That means what is h here? Minus 2 plus or minus a 2 by e 3 by 2. So x is equal to minus 2 plus 4 by 3 and x is equal to minus 2 minus 4 by 3. Okay, so that means 3 into minus 2 minus 6, minus 6 plus 4 minus 2, x is equal to minus 2 by 3, 3x is equal to minus 2, 3x plus 2 is equal to 0. That is one equation. And minus 6 minus 4 minus 10 by 3, 3x is equal to minus 10, 3x plus 10 is equal to 0. So these are the equations of directrices. Next, length of the lattice rectum. Length of the lattice rectum. What is the formula for length of the lattice rectum for this type of hyperbola? 2b square by a. So 2 into b square 5 by a 2. 2 to cancel, so 5 is the length of the lattice rectum. So similarly we can find the length of the transverse axis 2a, length of the conjugate axis 2b. Next, vertices formula, actually plus or minus a comma 0, right? So h plus or minus a comma k. So by using this formula we can find. So like this we can, first of all we convert into any one of the 4 forms and then compare, find h, k, a, b and eccentricity, then find remaining all. So to solve this problem we should remember those all formulas. Okay, right? These are the similar problems of previous problem. So these are the equations of the hyperbolas questions. So convert these into one of the 4 forms. So you will get, you have to get this form and compare and find center, foci, equation of directrices, eccentricity and length of the lattice rectum. Okay, so solve all these problems. This is the work for you. Okay, solve. Now one more important question. Find the equations of the tangents to the hyperbola x square minus 4y square is equal to 4. This is the hyperbola and we have to find the equation of the tangent which are parallel to, this is the line x plus 2y is equal to 0. Now we should find the parallel tangents to given line. Okay, simple problem. So given what is given hyperbola? X square minus 4y square is equal to 4. Divide with 4, you will get x square by 4 minus y square by 1 is equal to 1, right? So compare a square 4, then a is equals to 2, b square is equal to 1, b is equal to 1, right? Now equation of tangent parallel to parallel to x plus 2y is equal to 0 is x plus 2y plus k is equal to 0. Already I given one formula in ellipse chapter. If a line is parallel to ax plus by plus c is equal to 0, then the line equation is ax plus by plus k is equal to 0. The two parallel lines are differ by a constant only. Okay, so the tangent equation which is parallel to x plus 2y is equal to 0 is x plus 2y plus k is equal to 0. So here the point is x plus 2y is equal to 0 x plus 2y is equal to 0 is a line which is passing through origin. So we have infinitely many parallel lines to this line. So we have many parallel lines. In those infinitely many parallel lines, only two parallel lines touch our hyperbola. We should find those hyperbolas. So for that, apply condition for tangency. Okay, so what is the condition for tangency? Compare with L, M, N. Lx plus my plus n. L is equal to 1, m is equal to 2, n is equal to k, right? So what is the condition for tangency? Condition for tangency is n square is equal to a square m square minus b square n square is equal to a square l square minus b square m square. A square l square minus b square m square. What is n square? K square. A square 4, l square 1 square 1 minus b square 1, m square 2 square, that is 4. So 4 minus 4 0, then k is equal to 0. So if we substitute k is equal to 0, then expressed. So therefore equation of tangent is what? X plus 2y is equal to 0. That is only, that's itself only tangent. That means so like this is the tangent for both pieces. X plus 2y is equal to 0 touches both pieces, only one and only one tangent. So itself only, right? Next, second one, equation of tangent perpendicular to x plus 2y is equal to 0 is, so I given one formula, ax plus by plus c is equal to 0. The perpendicular equation to this one is bx minus ay plus k is equal to 0. Okay, so then b, what is b? 2x minus a 1y plus k is equal to 0. So this is the equation. So here also we have infinitely many perpendicular lines to this, infinitely many. So in those infinitely many, maybe 2 or itself one only. Okay, one or, so one means this one, 2 means like this. Okay, so we should find those. Okay, so these perpendicular lines should be tangent to our hyperbola. Therefore again apply condition for tangency. L is equal to 2, m is equal to minus 1, n is equal to k. So then condition, what is the condition? N square is equal to a square l square minus b square m square, n square k square, a square 4, l square 2 square 4 minus b square 1, m square minus 1 square 1, 4 4 the 16, 16 minus 1 15. So k is equal to what? Plus or minus 15. Substitute in this one. So the required tangents are 2x minus 1, one is plus root 15 and another one is minus root 15 is equal to 0. So these are the two tangents which are perpendicular to given line. So observe the concept, understand the concept and solve the problem. Find the equations of tangents to the hyperbola 3x square minus 4y square is equals to 12, which are parallel to the line y is equal to x minus 7, perpendicular to the line y is equal to x minus 7. So same similar problem to previous problem. So solve yourself and you should get these answers. Okay, next problem. Find the equations of tangents drawn to the hyperbola 2x square minus 3y square is equal to 6, through one point. This point is this point is not on hyperbola. Remember this thing. So if a point is on hyperbola, we should follow one method. If it is exterior to the hyperbola, there is another method. Okay, right. So here point is not on the hyperbola, so first convert it into standard form. So divide with 6, you will get x square by 3 minus y square by 2 is equals to 1. So a square is equal to 3, then a is equal to root 3, b square is equal to 2, then b is equal to root 2. Right? Now the discussion is about tangent line. We should find the tangent line equation, right? So for that, what is the equation of the tangent line? Equation of tangent line through point 2 comma minus 2 comma 1. Let us assume that the slope of the tangent is m with slope m. Okay, then what is the equation? Y minus y1, 1 is equal to m into x minus x1, that is x plus 2. Y minus y1 is equal to m into x plus 2. So y minus 1 is equal to mx plus 2m, right? Now mx minus y 1 plus 2m is equal to 0. So this line is tangent to hyperbola. So then it must and should satisfy that condition, that is n square is equal to a square l square plus b square m square. Okay, so here what is L? Compare with Lx plus My plus n is equal to 0. L is equal to m. M is equal to minus 1. N is equal to capital, I am denoting with capital, n is equal to 1 plus 2m. So L, M, N we got. So this line should be tangent to our hyperbola. For that, it should satisfy this condition. N square, that is 1 plus 2m whole square. A square value 3 into L square, M square. B square 2 into m square minus 1 square. So 1 plus 4m square plus 4m a plus b whole square, 3m square plus 2. So rearrange the term, 4m square minus 3m square, m square plus 4m minus 1 is equals to 0. Here I did small mistake, that is the formula is minus not plus. So here minus to bring to left side, that is plus 2 plus 1, that is plus 3. So the factors are m square plus 3m plus m plus 3 is equal to 0. M common, m plus 3, 1 common, m plus 3 is equal to 0. M plus 3 common, m plus 1 remaining. Okay, so from this we will get m plus 3 is equal to 0 means m is equal to minus 3 or m is equal to minus 1. So substitute these values here. We will get so if case 1 m is equal to minus 3, then this one substitute in 1 minus 3x minus y 1 2 into minus 3 minus 6 is equal to 0. So minus 3x minus y minus 5 is equal to 0. That means 3x plus y plus 5 is equal to 0. So next case 2, if m is equal to minus 1, this implies minus 1 into x minus y 1 plus 2 into minus 1 is equal to 0, minus x minus y minus 2 plus 1 minus 1. So that means x plus y plus 1 is equal to 0. These are the two tangents. One is x plus y plus 1 is equal to 0 and another one is 3x plus y plus 5 is equal to 0. So these are the two tangent equations from exterior points. Next problems. if 3x minus 4y plus k is equal to 0 is a tangent to x square minus 4y square is equal to 5, then find k. Simple problem, already just now we did this type of problem. First convert into standard form. For that divide with 5, minus 4y square by 5 is equal to 5 by 5. So x square by 5, y square by 5 by 4, bring to denominator is equal to 1. So compare, then we will get a square is equal to 5 and b square is equal to 5 by 4. Now compare this linear equation with lx plus my plus n is equal to 0. We will get L is equal to 3, m is equal to minus 4, n is equal to k. So what is the condition for tangency? Condition for tangency. Condition for tangency. What is the condition? L square n square is equal to a square L square minus b square m square. So n square, what is n square? K square, a square 5, L square 3 square minus b square 5 by 4 into m square minus 4 whole square. So k square is equal to 9 5 is 45, 1 4 gets cancelled, 4 square 16, 4 4 is 16 minus 20, this is equal to 25. So k is equal plus or minus root 25. So finally k is equal to what? Plus or minus 5. Okay, like this we can find k value. And last problem of this lecture, so that is find the equation of the hyperbola whose foci are, foci means plus or minus 5 is comma 0, that means lies on x-axis. The transverse axis length is given, this is 8. So length of the transverse axis, length of transverse axis is 2a is equal to 8. So a is equal to 4. You should remember the formulas. Next, foci. What is the foci formula? Plus or minus ae comma 0 is equal plus or minus 5 comma 0. So ae is equal to 5, 4e is equal to 5, e is equal to 5 by 4. So next, b square formula, a square into e square minus 1, a square into e square minus 1. So what is a square? 4 square, e square 5 by 4 whole square minus 1. So 16 into 16 LCM, 25 minus 16 cancel. So b square is equal to 9. So finally equation, what is the equation? X square by a square minus y square by b square is equal to 1 is the equation of the hyperbola. A square means 16, b square 9 is equal to 1. This is the required equation. So like this we can solve the problems in easy way if we learn the formulas and the concepts clearly. Okay, so for that rewind this video again and learn the concepts, note the formulas and revise. Okay, so we may get Iit-Jee problems and Eamcet problems from this chapter also. So asymptotes, rectangular, hyperbola, like that very important concepts are there. So go through those concepts and practice well. So next in remaining video I will explain remaining problems of exercise 5a. Okay, thank you.